This is a walkthrough of Exam 1B in Physics 131 from the Fall 2021 semester. Subject is 1 and 2-dimensional motion. Problem 1. A blue car is traveling at a constant speed of 100 kilometers per hour west. A red car is traveling east at 80 kilometers per hour on an east-west highway. They are currently 210 kilometers apart, heading toward each other. How far apart will they be when they are 30 minutes from passing each other? Good diagram. There we go. Blue car, red car on a highway. This blue car is going 100 kilometers per hour. Red car is going 80 kilometers per hour. Now, let's think. In an hour, the red car is going to go 80 kilometers and the blue car will travel 100 kilometers. That's 180 kilometers. If they were 180 kilometers apart right now, they would pass in 1 hour. So, if they're going to pass in a half hour, they must be 90 kilometers apart. That's it. That's the answer. Number 2. An orange car and a purple car are side by side at rest at a stoplight. The light turns green. The orange car accelerates at a constant rate, 4 miles per hour each second. The driver of the purple car is not paying attention. The light changes, starts to accelerate later. There's some delay. T sub D. The acceleration of the purple car is 6 miles per hour per second. The purple car is going 30 miles per hour when it passes the orange car. What is the time delay between the orange car starting and the purple car starting? Plot the speeds of both cars on the graph provided. Good diagram is so useful here. Here they are at the stoplight. Purple car and the orange car. Light turns green. Everything's at rest. Light turns green. And the orange car goes. Purple car still here. There's a delay. So we have time equals t delay. The purple car is just about to go. The velocity of the orange car is greater than 0. It's taken off, accelerating at 4 miles per hour each second. Velocity of the purple car is still 0. Then the purple car goes, accelerating at 6 miles per hour each second. And eventually, the purple car passes the orange car going 30 miles an hour. So the purple car is driving for 5 seconds. The purple car accelerates 6 miles an hour each second. It takes 5 seconds to get to 30 miles an hour. The orange car has been driving longer, a little bit longer because it started earlier. T is 5 seconds, velocity of the purple car 30 miles an hour. So let's calculate how far the purple car has traveled. It's just pretty straightforward calculation. It averaged 15 miles per hour for 5 seconds. How far do you go when you average 15 miles an hour for 5 seconds? Well, that's 75 seconds per hour, but that's not a very useful unit of distance, so we express it in feet, and we get 110 feet. Purple car went 110 feet in 5 seconds. The orange car also traveled 110 feet, but in a longer time. So the relevant question is, how long does it take the orange car to travel 110 feet when starting from rest and accelerating at 4 miles per hour each second? So let's calculate it. X is 1/2 at squared plus VIT. The initial of the orange car is 0. So that's the distance it has to go. 1/2, 4 miles an hour, t squared. We can solve the t for the orange car. So we solve for t, take the square root, we get 6.12 seconds. So the orange car has been driving for 6.12 seconds. The purple car has been driving for 5 seconds. The time delay is 1.12 seconds. Now we have to plot the speeds. So the purple car stays there for 1.12 seconds, then accelerates. The final speed of the orange car, it's accelerating 4 miles per hour each second, and it does it for 6.12 seconds. It gets up to 24.5 miles per hour. So here's the orange car. Starts from rest, light turns green, and it takes off. 4 miles an hour every second. At 1 second, it's going 4, 2 seconds, it's going 8, 3 seconds, it's going 12, 4 seconds, it's going 16, etc. The purple car is stuck at the light. Its speed is 0 for 1.12 seconds, and then it accelerates at 6 miles per hour per second. The slope of the purple line here is 6 miles per hour per second. The slope of the orange line is 4 miles per hour per second, and at 6.12, the purple car passes the orange car. Purple car is going 30 miles an hour, orange car is going 24.5 miles per hour. That's problem 2. Problem 3. An archer with a compound bow shoots an arrow at a speed of 200 miles per hour, 40 degrees above the horizontal at a vertical cliff, 102 meters high, 600 meters away. Does the arrow make it over the cliff? If yes, where does it land? If no, where does it hit the cliff? Okay, so let's put some labels on there. That's 102 meters. That's 600 meters. Here's the initial velocity, 200 miles an hour. So we have to convert that to meters per second to make our lives easier. 89.39 meters per second is 200 miles an hour. Now we get the horizontal and vertical components. Horizontal is 68.48, so it's going to go about 68.5 meters every second in the horizontal direction. Initially, in the y direction, we have 57.46 meters per second, so it's going to take 5.7 seconds to get to the peak, which is going to be somewhere over here. Now let's check to see if the arrow makes it over the wall, the cliff. To do that, we just have to calculate the height of the arrow after it goes 600 meters horizontally. We know the speed in the horizontal direction, 68.48, and we know the distance in the horizontal direction to get to the edge of the cliff, 600 meters. So we can calculate the time. It's 8.76 seconds. So now we can use this time to figure out the height of the arrow at 8.76 seconds. Here's the equation of the vertical direction. We can calculate y, and we get 119 meters. So it's going to be over the cliff. It's going to land somewhere over here. It's not going to hit the face of the cliff. It's going to make it over the edge. So now we have to shift gears. We know the vertical displacement of the arrow is going to be plus 100 meters because it's going to land up here. The arrow started down here at y equals 0. It's going to end up here at y equals 100 meters if we use the level 0 where the arrow was shot. So now we plug in 100 for y, plus 100. The acceleration is always minus 10. There's the initial speed in the y direction, and we calculate the time. And this is a quadratic. We use the quadratic equation, and we leave out the units. So here's the quadratic. There's going to be 2 times where it's 100 meters off the ground. One of them is back here. We don't want that one. 100 meters off the ground here, and then 100 meters off the ground again here. We want the larger time. And it turned out to be 9.35 seconds. So now all we have to do is figure out the horizontal displacement at 9.35 seconds. There's the speed in the horizontal direction. There's no acceleration. There's the time to hit the top of the cliff. So we get 640 meters. So the answer is 40 meters away from the edge of the cliff. The arrow hits the top of the cliff 40 meters from the edge, right there. And for extra credit, you can calculate the angle of the arrow when it's sticking out of the ground. That's exam 1B.